Hello, I am Civil Air Patrol Captain Scott Munns from Wisconsin Wing, where I serve as Director of Unmanned Operations. The purpose of this video is to acquaint you with the WebODM software, which can be used to create orthomosaics from a collection of images that you would have taken with one of your SUAS. We will go over the installation process, and we'll also go through the basic steps of the workflow so that you can create your first orthomosaic deliverable. The first step in the process is to install the WebODM software. To do that, we have to download it first. This is the WebODM website, webodm.org. And so if I go there, it comes up with a download link right at the top. If I click that, you will see that it has versions for Windows, Mac OS, and Linux. On Linux, it will only run using Docker. On Mac OS, there is an installer, or it can run on Docker. And on Windows, it can run with an installer or with Docker. For the purposes of this demonstration, we are going to focus on using the native installer for Windows because that will probably be the majority of folks that will want to use the tool. So the first step is to download the installer, which is pretty simple. You'll start just by clicking on the link here. I'm using Chrome right now, so if, that will affect how this looks as far as things in the browser. But we have a download in progress. It's a fairly large download, about 519 megabytes, so that might take you a while depending on the speed of your internet link. When the download process completes, we can look in the download folder and we will see that WebODM setup has been downloaded. I can click Show in Folder, which takes me to the Downloads folder. Do a quick refresh, and here is our installer. So I'm going to double click the installer in order to run it and continue the process. It may ask you for a PIN or a password to continue, so if necessary, please do that. And then the installer opens up. The first step is to accept the license agreement. Next, it will ask you for a location to install. This is where the amount of space you have available on your disk is critical. I already said that the installer is about half a gigabyte, and the exploded size of that installer is quite a bit bigger than that. It wants to install at the top level of a hard drive in the WebODM folder, and that's the only allowed option. On my particular machine, the C drive is quite full, and so I cannot use that. I won't have enough space either for the WebODM software or for project files that are created while making orthomosaics. So I'm installing to an external 5 terabyte hard drive that is under the E drive letter. So that's what I've chosen here, but you can choose what makes sense for you. You can see that I don't have anywhere near enough space to be adequate on the C drive and to have any kind of breathing room left over. So I click Next. And it will ask me some questions about whether I want to put something on the Start menu, and I accept the defaults. And the same for the desktop shortcut. You can add one if you want to, but I don't. Finally, it gives you a chance to double check everything and make sure it's the way you want it. And then you can click Install. The installation will take a while, so I will come back after it is completed. After the files get installed, final step is to finish, and in this case we will also launch the WebODM tool so that we can continue and build our first orthomosaic. The startup process can take quite a while. and so be patient with it. Um, as far as the machine that you should use here, again, we talked about hard drive space needs being substantial to create multiple projects. Also, I would recommend an absolute minimum of 16 gigabytes of RAM. 32 is better. In fact, any amount of RAM you can do above 16 is great, and I would encourage you to use as much of it as possible. It will allow you to do larger projects and should positively impact the speed as well. So when it finally starts up, we get a dashboard that looks like this. You can see that it has already created a single project from that we could use, but I'm going to add my own project in order to have to show you what the add project looks like. So if I click add project, it's going to come up with a name, and you can put in an additional description if you want to. And let's call this demonstration. So if I create the project, it sits here just like first project does. And the next step is to select images and GCP. GCP stands for ground control points. For most Civil Air Patrol work, we won't have ground control points, and so we'll just be selecting the images that we want to create the orthomosaic from. I have a folder with some image sets, and we're going to use a set that includes a baseball park that was provided by Bruce Davies from Ohio Wing. So I've selected all of the image files, and now I'm clicking open, and it will start the process of loading these. And you can see very quickly it has looked at the files and has identified their locations by the GPS coordinates embedded in the image metadata. And so now it will allow us to look at that, make sure that we have all the images we expect and the spacing we expect. And since that looks good, I'm going to continue. The next step in the process is to select our options, and there are many. The first decision we need to make is whether we should resize images, and for the sake of this project, I'm going to say no. If I were to say yes, it would give me an adjustable number of pixels. And in order to figure out what you should use here, I would recommend that if you're going to resize images, that you use the large number of the two numbers in the size of the images that come from your camera, and divide by 2 as a good size to use to resize images. That should cut the image size about by a factor of 4, and will also cut your resolution in half. So there is a consequence of doing that, but it's an efficient way to do it if you use half of the size of the source image, and it can also help you if you're running low on memory or processor. For the purposes of doing one of these orthomosaics, you may need to use resize images, but for the sake of this example, I am not. The next area we have is several different options, and you will see here that we have different options that are available to us. There's the default option set, and then there's also others for high resolution or forests or buildings or other things like that, and they make small adjustments to the settings that work best. Now the default set of settings chooses an orthophoto resolution of 5 centimeters per pixel, which is about 2 inches per pixel. And that's fairly good, but it can be better depending on the specifics of your image, including the sensor you use and the altitude you fly at. And so you can do much better than that. And that's why there are some other options like high resolution that you could choose from. I like to start from a specific set of options like default, and from there make my own individual edits. And so to do that, you click Edit here, and now you get a long list of potential settings. And this can be a little daunting, but there really are only a few that you might need to use on a regular basis. And so we're going to go through those. The first section is around input and pre-processing. I think you should work well by just using the defaults here. The next section is bounds and cropping, and I do recommend that you utilize the auto boundary setting, which, like it says here, automatically sets a boundary using camera shot locations to limit the area of the reconstruction. There are several other settings here as well, but we will leave the rest of them alone. Structure from motion is a very important piece of the way that the algorithm works to create orthomosaics. The defaults here usually work quite well, and I will only highlight a couple of things that you might want to play with. The default algorithm DSP Sift works quite well. There are some other choices you could try. For feature quality, high works pretty well. There is an ultra. I will warn you that if you try ultra, it will run quite a bit slower, and in some cases you may not be able to get an orthomosaic at ultra feature quality. Min-num features is also something that you can adjust upward if necessary from 10,000 maybe to maybe 25 or 30% higher if necessary in order to get some orthomosaics to stitch together. These other algorithm choices like FLAN and other matcher types I'm going to leave alone for now. You can experiment with them on your own, but these work pretty well. So no immediate need to change any of these right now. The defaults work well. Point cloud also has some options here, and I'm not going to touch those. We're just going to work with those as they are. Meshing is an area that you can sometimes play with to improve the quality of an orthomosaic. There are a couple of options especially that I would consider, and that's the mesh octree depth. And if you want to get more vertices in your reconstructed mesh, you can choose up to 12, or you can go higher, but I wouldn't recommend any higher than 12. For the mesh size, 200,000 is the default. I have used values as high as 300,000, and so your mileage may vary, but it's something you can experiment with. In the texturing section, there are also several features or settings we can adjust, but I have not needed to change any of these for my projects. For digital elevation models, I am going to check some boxes here just to show you what they're like. DSM is a digital surface model, and we'll look at the resulting deliverable at the end. Digital terrain model is slightly different, where it tries to figure out where it thinks the ground is, even if there are other things sticking up from the ground. And again, if we look at resolution here, this is the centimeters per pixel that it's going to create the digital surface map or the digital terrain map at. And so again, it's going to do it at 5 centimeters per pixel, even if the images could do better than that. If the images cannot do that well, it will limit itself to only doing as well as the images themselves can handle. So I'm not going to change any of these other settings. I would consider those opportunities for experimentation. Orthophoto is another important one. Again, we're going to do this at a 5 centimeter per pixel orthophoto resolution. And I'm going to recommend that you turn on this orthophoto cut line. In some circumstances, this can help you. It will create a polygon around the area that you're trying to create your orthomosaic from, and it can help in building large orthomosaics in the future. Next setting is tiles, and we will not use tiles for right now, so I will leave these as is. System and pipeline control. This is an area where I am going to adjust the max concurrency. This is basically how many threads it's going to try to run at one time. Normally I would run this with 16, which is the maximum number that's available to me, and things may not turn out well if you try to set this to a larger number than the number of threads that your processor can run simultaneously. So consider this an upper limit. I'm going to set mine to 12, which may run a little slower, but the reason I'm doing that is because I'm doing this video and I want to leave some cores and some threads available for the video processing that's being done while I create this video. Down here it has some options for where you want to rerun from or end with, so you can control what step of this overall pipeline you start from and end at. And this works well if you're going to go back and just make some adjustments, and maybe you don't need to redo all the steps in the process based on the settings you're going to adjust, and then you can just redo the steps that are necessary to redo and nothing more. The final area is split and merge. We will only look at using this when we are doing a very large orthomosaic that we can't possibly run without running out of memory otherwise. What we're doing here is we're limiting, by changing the split setting, we're limiting the number of photos that will be used at one time to build sub-models of our overall orthomosaic. So if I set this to 300, it's going to select groups of 300 images that it will create submodels from, or like smaller orthomosaics from, and then it will stitch those together to create the bigger orthomosaic. And this split overlap is how much overlap in meters there is between the different orthomosaics that are being created, these submodels. And 150 is a default. This would work with ground control points. It is recommended to use 200 meters if you don't have ground control points. But we're not going to use these features at all because our model, our number of images is quite small, and there's no need for it on our machine. And with this example. So that's all of the settings. And so now we can click Save. The last step is to click Review, and it will tell us which settings are different than the defaults. So we can review this and make sure that this is what we intended, and if necessary, we can go back and adjust it. So when I'm done with all of this, and I'm happy with it, I go ahead and click Start Processing to begin the orthophoto creation process. Now we are ready to actually start processing. The first step in the process is to actually upload the photos into the WebODM project. You might think that we were doing that when we selected the photos the first time, but it actually is going to kind of do it again, and it takes more time. It's going to move the files and create a copy of the files in the location where it actually runs these projects. And there are 149 images in this project, so it takes a little while. When this process of loading the images up completes, now it will continue by sending images to processing node. This is just details that you don't need to worry about. At this point, you'll see a task outputs toggle button, and I would recommend switching this to on, which will tell you a running log of what the project is, what's being done in the processing as it runs the orthomosaic. This process is going to take quite a while, so I am going to go ahead and let it get closer to completion, and then I will come back and we will talk about the results and how to view the results and download the results. At the end of the whole process, you will see this last line, compressing all.zip. And you'll also see a thumbnail of the orthomosaic show up in the upper right hand corner. And then you will have the option to either view deliverables or um, get views of the things you've created using these three buttons to the right, map, 3D model, and report. Or you can click download and start downloading deliverables, which I'll show you how to do 2 of those. So first thing I'm going to have you do is look at the map view of the deliverables you just created. So first it starts by showing Google Maps in the background, and then it shows your new orthomosaic on top of it. And it also gives you a slider at the bottom so that you can look at the original in Google Maps and then bring in your own. You also have some ability to zoom in. You get a sense of the accuracy you had. Remember, we are doing 5 centimeters per pixel, and 5 centimeters is about 2 inches. So that's about what you're getting here. It looks about right. So you do lose some resolution. We'll see just how much when we get to the report that is generated. But and we could potentially do better, but it would take longer to run. So this is your orthomosaic deliverable and the viewer for that, so you can get a quick look at it before you start downloading files. If you click on surface model up here, this will show you what that surface model is that we created. It basically creates a color-coded or contour plot, colorized contour plot of the heights of everything within the space of what the images were taken. And if you then look at terrain model, it uses an algorithm to try to figure out where the ground is as opposed to the structures. So you see it if you compare terrain model and surface model shows all of the things that stick up, and the terrain model tries to get rid of things that stick up, like little buildings or trees or other things like that. It can't do it perfectly because it's just using an algorithm. It doesn't really have access to additional information, but it tries. If it were me, I would focus more on the surface model if you're trying to understand elevations of things, and then obviously the orthophoto for the visual view of what's going on. The other thing that you can view in here is this 3D view, which is obtained using a point cloud. So it's going to pull that up here quickly. So this is more of a 3D view where you can actually rotate it and things like that. If you double click on it, you can zoom in. It's not as accurate as the orthophoto, but you at least see what it is, what it was building, and the points that it found as a result of doing the combining all of the images together. You can see what it was doing with the trees and things like that. So these help you to get a better understanding of whether you really have a good orthophoto or if you are getting a whole bunch of artifacts in your image. That all looks pretty good. So if I go back to the dashboard, I'm going to have to click on tasks again to get the view to show up. Now, the first thing I'm going to demonstrate is how to download just the orthophoto. And when it did the orthophoto, it actually did it in automatically in the Universal Transverse Mercator format, UTM, for the specific zone where the GPS coordinates are at. And normally, we don't use Universal Transverse Mercator. It makes a good map, but we usually like to see things in latitude and longitude. In order to do that, we actually have to go through a coordinate transformation, which is an additional step. So if I drop down here, you can see that I can select EPSG 4326, which is latitude longitude. If I pick that, I download, it's going to actually convert it and download the file. So it'll take a little longer, but it's going to give me that TIFF file. So if I have a demonstration folder in my separate WebODM projects folder. That's just how I organize my projects. It wasn't automatically created for me. I save that. Now if I open it, this is what the file actually ends up looking like, and you can zoom way in on this. And it's a little distorted by the latitude-longitude transformation because latitude and longitude are not the same number of miles depending on what latitude you're at. But we like the view, and if you bring it into a tool like QGIS, it will show its coordinates in latitude and longitude, which makes it easier to pull lat and long off of clues and things like that. So frequently we save in 4326 format. The other thing that we can do is simply to view, before I download everything, I will click on the report. And this is a PDF file. It's very nicely done. And it will show you some statistics, how many images, the ground sampling distance. It thinks that it could achieve 2.5 centimeters. So if we asked for less than 2.5 centimeters, it would limit out at roughly 2.5 centimeters, maybe a little bit less, so as not to waste anyone's time trying to get accuracy that doesn't really exist. But it'll also show you views of the space and where it found things for the images. It will give you previews of the different deliverables, just smaller, a little bit bigger than a thumbnail, but smaller than the full image. Also this is a very nice view where it shows the survey data and shows you how many pictures on average were in each area of the image. So it gives you an idea of where you should trust the orthomosaic and where you might not trust the orthomosaic. And of course, generally, you don't trust it as much around the edges because it is not getting as many images to build the orthomosaic from. And there are a bunch of details about GPS errors that can help you check things. And there are details about the camera and how what it estimated for focal length and other things like that. So it just, again, this is all just to give you hopefully a warm fuzzy about how it all went, and that if anything looks a little crazy, then that's a clue that you might not want to trust it so much. So again, if we go over to downloads, you can pick any given one that you want to download, or, and this is what I would recommend, that you just do the all assets. And if you do all assets, it's going to download everything as a zip file, and then it's just a question of where it's going to put it. And in this case, I'm going to put it in that demonstration folder. Save it. Give it a little bit because it's a big file. Come in here. Let's say I look at the details of this. Detail view. You can see it's a very large file, 786 megabytes. If I go into that thing, you'll see that it has the report, it has details about, it has the full orthophoto, and a bunch of other stuff. Now this orthophoto may actually be in the original UTM units rather than the 4326 units. So I would recommend that you always download the orthophoto separately to make sure you get it in the units that you want. And all the other um, all the other um, deliverables are also here. File sizes are quite large. At some point, you will run into limitations just based on being able to open your created image in the amount of available memory. So there's always a limitation on how big of a problem you can tackle at a time. So that concludes the overall process of getting deliverables out of Open WebODM. And so thank you for your time. I hope you have success with it, and feel free to reach out if you have questions or problems. Thank you.